Okay, so we have one more problem. This one, though, involves the chain rule, so we're building up on top of the previous ones. So you have f of x equals, and now I told you that whenever we're looking for derivatives, roots are not our best friend. So let's rewrite this as x squared, oops, I wanted my white back. X squared plus x. And now remember how I told you about like forming the exponent, that whatever's the root number is in the denominator, and then whatever the exponent inside of the radical is your numerator. But in this case, we don't really have an exponent for the whole expression, right? If this was like cubed, then we would have had 3 here. But we don't have an exponent explicitly written, which actually means it's just 1, okay? Therefore, we're gonna have 1 in the exponent when rewriting, okay? All right, good stuff. So from here, we want to take the derivative, but here's the catch. We have one function here, which is to calculate x squared plus x. And then we have a totally separate function to take that result and raise it to the power of 1/4, right? So these are two functions built inside of each other. The inner is x squared plus x. Okay, and then outer is take that entire thing from the inner and raise it to the power of 1/4. Okay, good. And now how do we calculate derivatives when we have composite functions? How do we use the chain was it chain rule? Yeah, that's chain rule. I kind of forget the names, but even if it's inaccurate, you know what I mean. I believe this is chain rule. So how do we apply? First thing we need to do is we take the derivative of the outer function while keeping the expression inside the same. So if the expression is x squared plus x, we're not gonna touch it right now. We only take the derivative of the outer function. So the outer function is something to the power of 1/4. Therefore, I apply the regular rule, so I bring the 1/4 in front. I keep the something in the brackets the same for now, so I'm not gonna change it. It's still gonna be x squared plus x. And now for the new exponent, I have the old one, in this case 1/4, minus 1. Just like we always calculate derivatives, right? So 1/4 minus 1 is 1/4 minus 4/4, which is minus 3/4, okay? But then we're not done. We only went through the derivative of the outer function, but now we have to multiply by the derivative of the inner function. This is our inner function. So same rules apply. We bring the exponent to the front. This is going to be 2. We keep the x untouched. And then the new exponent is going to be the old one minus 1. So 2 minus 1 is just 1. I don't even need to write it. This thing is going to give me a derivative of 1, right? So it's going to be, actually, let me put this in brackets like this, plus 1, okay? Because it's going to be 1 times x to the 0th power, but that's just 1. Okay, and now I keep going. Actually, there isn't much to do here. You could leave it at that, or you could... So let me just write it. Or you could potentially, you know how, when you have multiplication, you can bring this to the denominator, but raise to the positive power, okay? But you don't have to do this. You could literally leave it at that and it would still be correct. And that's actually your solution. You just need to be good at recognizing the functions. So you have one function inside, which is like calculate x squared plus x. You have another function, which is like calculate the 4th root, or in this case, the 1/4 power of whatever is inside. So 2 separate functions, and you need to take them into consideration. So the derivative is equal to the derivative of the outer function times the derivative of the inner function.